Deral Heiland, and the name of this is Plunder, Pillage, and Print.
Thank you very much.
Take it away.
So I guess we'll get moving along real quick. I'm not sure if everyone was expecting to be in my presentation. It kind of collapsed into this, I guess. So this is a real interesting topic, and we've been doing this for a number of years and leveraging this information during pen testing and educating customers in what not to do when it comes to embedded devices on their network. A little bit about myself. I'm a senior security consultant for CDW Corporation. I travel around the country doing pen testing assessments, evaluating corporate security. I live in Ohio. I've been doing IT for over 20 years. 10 years in security, 5+ as a consultant, also a member of the FUFASnet team. If you're a pen tester, you may be familiar with tools like Medusa, FGDump. Those come out of the FUFASnet team. So embedded devices. So this whole talk's generally about embedded devices. We're going to pay a little more attention to printers. But when I talk about embedded devices, it's literally all embedded devices. Everything from multifunction printers to wireless controllers, routers, switches, storage management devices. Generally, what we're looking for is any device we can get usable data out of. So the most common factors of failure when we're dealing with embedded devices, and I see this on every corporate network. Default passwords still enabled, common problem. Followed by poor product design, and then we all finish it up by never actually patching the devices if the vendor comes around and actually comes up with a solution to fix some of the stupid stuff that I point out. So as we're going through the presentation, I think we probably have the time. Don't hesitate to ask me some questions. If you have some input, to go ahead and stop me. Let's make this kind of an education training section here so we can all get something out of this. So what we're going to cover today, or what we're after, is typically Active Directory credentials. Anytime I'm doing an assessment, I like grabbing that stuff. Windows local credentials, the local administrator account, things like that. Unix, Linux host credentials, or Snmp community string information. All this data is available from a plethora of embedded devices that are existing on your corporate networks. So in today's agenda, we're going to go through a couple examples of pen test. It's kind of a pen test stories where we're going to point out examples. And in some of the examples, we're going to drill down into certain product lines so you can get a look and feel of how that data is actually pulled out of those devices and the methods that we use to do this. We're going to discuss processes, and we'll also talk about automating a lot of this. We have a tool called Preda that we've tried to automate a lot of this functionality of extracting data from your corporate network embedded devices. And of course, we can finish up with questions. So pen test story number one. So I hope you don't mind me walking around. I really hate standing in one place. It's kind of boring. And this one here, we're dealing with trying to gain Windows Active Directory creds from a device. And a little bit of information about this particular customer. Most of their systems are well patched, so there's no of the common vulnerabilities that we could leverage to gain a foothold to any of the devices. So we don't have that. Every Windows server in that environment had a different password. Most users had complex passwords, 9 or more characters, alphanumeric, things that you typically aren't going to be able to brute force. Also, they were a full Windows 2008, Windows 7 environment. So as you're seeing, here's a customer who's actually taking a real proactive approach to building their internal security a little more closer to the correct way of doing it. And users do not have administrative access to their systems. So the first day on the assessment, I didn't gain access to anything other than a few systems I was able to compromise. Was never getting that global foothold in the corporate environment. Now talking about embedded devices, up to this particular engagement, most of the time the work that I did looking at embedded devices were saved to the end of the assessment. Most assessments I go in, I hook up to their network within the first 60 minutes to hour and a half. I'm usually a domain admin within that time frame. But in this case, I'm on day 2 of the assessment and I've gained access to a few devices, but like I said, nothing global. So after this assessment, we moved the whole process I'm talking about here to the beginning of the engagement using that tool Preda, which we're going to talk about at the end. So we did find a number of embedded devices in this environment that had default creds. And most of this, we found that Canon Image Runner multifunction printers on this site actually had default creds. So it comes to the one question, how many people in here, now everyone pay attention to the hands that go up. So how many people in here at your location, the requirement for all printers is they must have their default passwords changed prior to be putting into service? Do we have anyone? So the numbers are going up, but as you see, we had 5 people raise their hands. You guys work for government-related entities? Okay, that's interesting. Usually I see that at some government-related entities, but I don't see it in corporate America. But as you see with all the people in here, we only had a few hands go up. And this is the common thing. I have only one time in 5 years of pen testing found an organization that actually had changed the default passwords on all their printers once in 5 years. So that's a key failure in our environments. So let's look at this. So our initial foothold happened to be in a Canon printer. And it turns out with the Canon printers, there's several problems when we're dealing with the older IR types. They have a newer one, IR-80Vs, advanced Canon printers, but we're going to go into a little detail on those. But in this case, they had the typical IR. There's 11 address books on an IR printer that you can extract off of those devices. And the cool thing on these older devices, at least 90% of them, if they haven't been patched to the latest firmware, there's a problem where you can do forceful browsing. So even if you set a password, I can get past it. And the way you get past it is, one, you hit the home page on the site, which assigns you a cookie. Now, cookie, you have to have the cookie, but once the cookie's assigned, then all you have to do is directly request the address books. And that's done with this URL right here. We can actually increment the AID up, 1, 2, 3, 4, to get through all the address books. If you go online and just look at the address books, you will not see user information. If you export the address books, you are going to see the detailed information, in this case including the path, the username, the user ID, and the password will be exported in plain text in the address books. In this case here, this turned out to be a domain admin cred. So we have an IT manager, and literally the director of IT was hacked. He was mad. He had set all this effort, all this time of years of hardening down his environment, and it all came to naught because of a Canon printer. We've used this hack on literally dozens and dozens of companies. Most of the time, they don't put a domain admin cred in there. The functionality on the Canons that you typically see in there is associated with scan to file functions. So the user could come up, he authenticates himself to the printer, he does a scan, and it stores it somewhere. In this case, it was a global scan, so it would save it anywhere they want using the domain admin creds. A lot of times you'll see those set up for individual users where it'll actually save the scan file to their workstation. And a lot of times that'll be local administrator account on the local workstation. Or it may be their individual user's account. So those are the type of information you get out of that. So I want to look at the Canon MF a little closer. And as I mentioned on the Canon, well, I didn't mention on the IR, but there's no default password set on the IR devices. User force browsery to gain access to the address book. So if there's a password, you can force browse to get access to the address books. By default, the address book exports the passwords in plain text. Pretty straightforward. Move forward a few years, the Canon RI-80V devices is the newest stuff. After I published all this crap, they came back and started fixing stuff. In this case here, you can't force browse on the new 80V devices. They set a default credential. So the administrative access is 7654321 with a password of 7654321, which, as you've seen with the hands that went up early, 90% of the people in this room will not change it. Passwords are not exported by default in the address books. That's another change. And if they are exported and you're able to be exported, they export it encrypted by default. They'll ask you for a password during the export and it'll encrypt those passwords. Yes, sir. That I don't know. But as you see, it really doesn't matter. I'll show you in a second. So here we are. We got a Canon IR ADV device. This is a 6055. Password is 7654321. Okay, now we're into the device. At this point, we click on Settings, Registrations. This takes us to this page here. If we go ahead and click on Set Destination, Address Book Export Settings, this is where you enable exporting the password in the file. You do the checks box, you save that data out, then you come over here and you come down to Data Management. At the bottom here, you click on Data Management, and you can do a import-export of the file. So here is the actual post job going out. And as you can see, nothing really changes here, okay? It looks similar to that URL I showed earlier. We go ahead and click on it, and now we get the password. It's encrypted, and of course they base 64 it because it's binary and printable. And it goes out that way, and that's how it's stored. So there you have that. We'll step back a little bit. We look at this whole post process. If we look down here, it says encode mode. The other one said encode mode 2. You change it to encode mode 0, and now we get the password in plain text. Okay. So now we're still able to do this, and we've used this like 3 or 4 times in probably the last month, because everyone's buying all the new printers. Yes?
What business does this device have having user IDs and passwords, period? Why is it not just going out to AD, passing the hash, and then getting the response back, period?
Well, yeah, a lot of them do that. They have Samba capability. I'm not sure why Canon decided to do this. I don't know their business model around doing this. I've tried contacting them. They don't always like talking to me, so. Nor are they going to give me their business processes around their mindset on that.
I mean,
but
this logic alone is a reason for avoiding it altogether.
Correct. The fact is, if you do not change the default password on your printer and you integrate your multifunction printer to anything in your business environment, I don't care what the model of the printer is, I can steal your data off of it and get those passwords. Every model of printer. If we have time, I'll show the method that we use for that at the end. So then we move on to, sorry I couldn't answer your question. So we move on to pen test stories. 2, kind of stepping off and getting away from the multifunction printer. And this was, I wanted to gain access to the Cisco infrastructure of a corporate environment. This happened to turn out to be a bank, so I'm like robbing the bank, okay? It turns out that their Cisco was the only thing we didn't easily get access to. On this typical pen test, we had domain admin in 60 minutes once we plugged into their network, a really crappy network. And they're like keeping somebody's money safe. So here's some methods you typically use, at least I use during a pen test, some of them, to gain access to Cisco devices. One way may be to, if they've actually used in AAA and they've tied it into their Active Directory, you just steal their network administrator's ID because you're already domain admin, and you use that to log on the devices. That's one method. In this case, they weren't using AAA, so the accounts were all local to the device. Another method you can typically use is you look through the file system and you find their stupid backups of all of their config files. You pull those out and you look in them and you find password 7, you reverse it, now you're into the device. We couldn't find those for some reasons. Apparently they weren't keeping backups. So the next thing is just SNMP private community string. If you have a community string for a Cisco device, you can pull the running config off the device remotely. There's many tools out there to do that. So that's the method we're going to use here. So how are we going to get that? Well, it turns out that this organization likes using SNMP, so they integrated most of their embedded devices with SNMP capabilities so they can monitor. So they were at least trying to do something vaguely right for whatever reason, I don't know. But it turns out here is this happens to be an APC PDU. What's the username for an APC PDU? What's the password? There you go, APC. So now we're into this device here. We come over, we click on networks, we come down here to Snmp Strings, we take a look at it. Wow, look what we got. We got the public and private Snmp strings for this device. Guess where they use that? On everything. Because it's simple. So now we took a lowly, stupid APC device and it's gave us access to everything in their environment. We're able to get access to, we're able to pull the running configs off all their major Cisco devices. And it turns out that they were also using password 7. If anyone's familiar with configuring a device, that's deprecated. You don't want to use it. It's a fixed key, so you can revert it right back to the password. So now we had administrative access. We also had enable mode access just by extracting these running configs. So you can see how the progression goes. These devices are used to get a foothold to move through the environment to compromise critical systems. Game over again. Yeah, that's the ultimate fix. And this applies across the board for any kind of embedded device, whether it's a password or whether it's a community string. You don't want to use the same strings of things of different security levels. My firewall is a different security level than a network camera or a APC PDU device or an APC UPS device. They're different security levels, so you don't want to use the same password. That's like the guy you hire, to sit at the front desk and answer the phones has the network access. You don't give him the domain admin password and have him set his as the same as the domain admin password. He's a nobody. Somebody compromises his account, they could use that password, eventually get to a domain administrator by just replaying the password. And it works the same way with all your embedded devices.
Just a point for everyone in the room, though. APC and its competitors, I've built out rooms within a room for data centers, the hot aisle containment solutions and stuff like that. And I've done them from multiple vendors, APC being one of the go-tos. This is your weakest link. This is one that you can find on every single audit because APC and these other competitive vendors like Liebert and all haven't addressed it yet.
No, APC,
although
Liebert,
think about it, yeah.
AAA, all the same.
Well, exactly. We think about it as a stupid PDU, and guess what? You can have all the security in the world, and the ultimate denial of service is just like what happened to Google over in Australia a couple weeks ago. If I've got the ability to get into your BMS, or more importantly, into your PDU management system with read-write strings that are less secure, I can literally shut down your entire data center or your critical components. It doesn't matter, router, firewall, or whatever. I just shut them off.
Yeah, that's a good point. I usually don't do that when I'm on assessments. People have a tendency to get all hacked off. But yeah, but denial services.
Go and look for that weakness.
And all APC, all these vendors majorly have default creds on all these devices. I walked into a room that had an APC device that was 8 feet by 4 feet by 6 feet tall, powered an entire data center. And the password's not APC. These high-end ones, they use something different, but in that customer site, it was still the default. So literally, I could shut down the entire data center completely. So yeah, these little devices need to pay attention to. And this is something I've been preaching for 3 or 4 years yet. And you know what the amazing thing is? When I started talking this at conferences about 2.5 years ago, when I went on an engagement, we leveraged this type of data to gain a foothold about 25% of the time. Since I've been preaching about it, I gain access now at probably 60 to 70% of the time. So it's actually getting worse. People are actually starting to figure out that, I paid $12,000 for this printer. I can do more than print with it. So they start integrating them into the environment, which is another complaint I had. Why pay $12,000 just to print? So we move on to pen test story 3. We wanted to gain access. This one we don't get domain admin, but the goal is get some kind of foothold. Again, most systems were well patched. The network was well segmented, which was a good process in place. All users had complex password. Literally, they were forced at 12 characters at this company here. Full Windows 2008, Windows 7. All users did not have admin rights to their machines other than IT department people. Okay, So then we move on to an interesting thing we're dealing with devices. A lot of multifunction devices, literally all of the newer multifunction printer devices have ability to do LDAP authentication, okay? So when you go to one of these printers, you know, it communicates to the LDAP server, and the LDAP server sends back the results. So what do we like to do? And this is the tack that works on every system, every one of them, 100%. So we come in as the evil attacker, and we log onto the printer with the same default password, and we just change the IP address for the LDAP server. So instead of it pointing to the actual LDAP server, it points back to us. Then we go ahead and trigger an LDAP lookup, and it passes the password to us in plain text. We've used this on, I lost count, every large printer that I found LDAP configurations on it. We've been able to use this. It was kind of interesting. Years ago, when you would go into the configuration page for an LDAP server, you could just look at the source of the page and actually see the password. So their goal to fix that was not put it in the source. Well, brilliant. But what they did was they let you change every other setting on the page without changing the password stored on the device. If they would force you every time you change the IP on the device to change the password, they would delete this problem, make it go away, but they don't do that. So things you can do with this, and we refer to this as a passback attack. If you go to the FUFASnet website, there's an entire paper written on carrying out passback attacks that we released about 2 years ago. So you can do passback attacks against Samba, and then we can set up a Samba server and capture the handshakes, and if it's an LM handshake, it's game over because you can reverse that with a rainbow table. SMT POP3 settings will work passback attacks, FTP, and LDAP. LDAP seems to be the most common one that I actually come across for being able to carry this out. And during this pen test, we happened to find a number of Sharp multifunction printers, in this case here. So if we look at this, this is a Sharp printer device. It's fairly straightforward. As you can see down here, there's a checkbox called Change Password. So you have to check that box to change the password. Other than that, you can alter everything on this page. So we can literally change the actual type. The screenshot here happens to be anonymous. But this can be changed to, I believe a lot of them have NTLM. So they'll do those types of Kerberos. They also have plain text. So even though you configure it to use like in NTLM or whatever, all I do is just change it back to plain text before I run my attack, and it's going to give it to me in plain text. So again, like I said, we change the IP address, we can change the port. I always like the idea of changing the port because I don't like always running like a netcat with super user privileges on my Unix box. So I run it at like 1389, and I change it in that way I don't have to run its root. Change the authentication type to be plain text, easy enough to do. Set up netcat as a listener, select test, and then trigger the printer, save that, trigger the printer, and this is what you get. Your netcat connects up, and if you break this all down, you can see we get the, in this case we get the domain, the username, and the password. The breakup is the question mark breaks up the username, and the username from the password, and the passwords end with a 0B. That happens to be a Sharp. It varies from device to device. It's not always 0B. I know on the Sharp it does, but I can't validate it on the other ones because I can't remember.
So why aren't they enforcing use of Kerberos? I mean, literally.
I mean, you know, if we go in and force the printer to only do one thing, you know, the people that want to use it aren't going to use it, okay? So we have these features, so not every environment's the same. Not everyone has configured Kerberos. Not everyone's configured the same way. So these printers need to be configurable. But remember, in my opinion, it's not the vendor's responsibility to take care of your stupidity, okay? And where's the stupidity is gaining access to these devices.
But here's the thing though, the vendor's field service reps are coming out and configuring the devices, and the client's getting charged an arm and a leg for that integration to happen.
Oh, I agree.
And you know.
Yeah, I don't disagree. I mean, if you're paying somebody to configure something, they should configure it correctly. And then we get into the same thing. When you buy a printer from a vendor, a local, you're in Boston, you call it whatever sells printers around here, and you say, hey, I want to lease 50 printers for 50 offices, and they're going to maintain it. They're going to come in and maintain those, and they're going to change the password. And they're going to change the password to something that everyone in their office knows, and is for every one of their customers throughout the entire city. So if you ever compromise any one of those, and we had that in an engagement where we went in and we noticed the printer was owned by a certain company that they leased it from. We went back to a previous historical research that we had done from a previous job where we kept notes of stuff like that, and then we used that to log into all their printers. And it's used by every way, so all their employees know what it is, and that's all the employees that have quit, all the ones that have been fired. It's never going to change.
If they're really, really tricky, they'll integrate something like the business name into the password.
Oh yeah, that's always a good one. Yeah, putting the name in there. So typically when I'm on an engagement, if I hit a complex password and it's something like that, I usually don't waste my time. I move on. There's 50 million other ways to hack somebody. So anything's better than nothing. Exactly. Anything's better than nothing when you're actually trying to secure these devices. So in this case, the game was not over. The user creds that we got there were limited access. So we typically weren't able to get domain ad privileges. So we got to go from there. So this is what we did. What you can get with a user with no rights. You can at least pull a list of users out of the domain. You can enumerate the domain control and get a list of all the users and identify all the domain admin users in the environment to carry out attacks against. That's a priv2 users, normal users, and we can gain access to the file system where everyone has rights. You create a user, he's given the rights of all users on the network. So if you have share folders and stuff like that, I now have access to that. Before we move on to this, that created interest. Well, let's go ahead and move on here. So with this one here, we had domain user rights. We searched the file server, discovered for password, the word password in the share folders. We actually found a number of files containing the word password. One of them happened to be sysprep. Okay, well there's two ways that sysprep's apparently used for rolling out Windows product type stuff. And there's two ways to configure it. You can configure sysprep so the password is actually encrypted. Or you cannot. They did not. So we had the actual local administrator password for all the systems in the environment from there. So from there, what we did was we went back to our domain list of all the domain users, identified everyone was domain admin. One of the other things they did was they named the individual workstations after the user. So now all we have to do is go, okay, John Smith is a domain admin. So we go to his machine called John Smith. We log on with this cred here. We download WCE. I don't know if anyone's familiar with WCE. Windows, what? I always get it wrong. Windows Credential Editor. And they got some new changes. You used to be able to pull the tokens with it. The token hashes, so you can replay the hashes. Well, they fixed that. So with the -W switch on the new version, you can actually pull the password in plain text. So here we're able to pull that domain admin user's password in plain text on the device. Now, game over. So we're able to gain that access. On another customer I was dealing with, I had used this same attack against a printer that was in the payroll department. And the user did not have any rights to anything. But it was used for the LDAP cred stuff we pulled, gave us access to a folder in the payroll department. And it turns out that that same folder, guess what a payroll department puts in folders? In this case, they actually put the entire payroll database backup in the same folder. So I was able to pull a large corporation with 1,000 employees' entire payroll system backup off onto my machine and strip all kinds of fun data out of it just because of a printer's LDAP settings. So any questions up to this point here? So then we get to a tool called Preda. Started working on this about 3 years ago, and this is a slow process. And the reason why it's a slow process is when I find a certain printer device and I find that I can pull information off of it, to write automation to pull that information off takes time. And a lot of times when we're doing assessments, I don't have time. So I don't always get a chance to create modules. So it's a slow process. And we're going to look at a little more detail of that. So Pareto stands for Plunder, Booty, Spoils of War. It's Latin. The original name I came up with, I won't say what it was. It was pretty bad. I can't even remember what the name was, but it was kind of weird. I found this name. Well, I can't read that far. 10 minutes? Okay. So the original name I came up with in Latin, I turned around and searched on the internet to see what it was. The name fit real well, the description in Latin, but it turned out to also be a tool used by a proctologist. And everyone goes, man, that's like totally cool. And I'm like, nah, I'm not even going there. So we stuck with Pareto. The current version is, and I consider this product beta, even though it's been out for several years. And we'll explain some of the shortcomings with it. We're version 2.1, and the last part, 72, is basically 72 devices that we can enumerate data from. We fingerprint the data using several things. The title page on the web, because we do this all through the web, mainly through the web interface part of it, of the embedded device. Title page, server type, and Snmp string. You can pull Pareto from GitHub right there. It can actually describe it real quick. It's made up of several pieces. We have a dispatcher. And what the dispatcher does is it takes some kind of input, IP input, GNMap input, and it compares it as it's touching each one of the devices against a flat file. And if it has a match, it runs the associated module for that device and pulls the data, parses the data. These are the switches, and you can get this from the README file easy enough. So let's kind of move on. And we have the ability to put IP input lists. So you can just take a list of IP addresses and say, hey, check these port 80 or 443, or you can do a GNMap input. So I thought the GNMap would be really cool, and it works really good 75% of the time. But I have noticed on a couple engagements, devices on the network, that Nmap will actually set them, say that they are some form of HTTP, when in fact they're not. So when this thing hits those, instead of just timing out, it holds the connection. So I'm trying to work out that bug right now. But I found out if you just purge all the Windows boxes out of the list, that problem about 99% goes away. But I need to work out those details. I haven't had any problems with the IP address and ports, so you can just parse a Nmap scan and grab everything that's 80 and 443 and 8080 that you know is actually a device, and feed that in and it'll work fine. So the output of this is a log file, web host, data. The log file contains all the discovered data. The web host contains all the fingerprint information, which is really cool because then you can go back and look for other devices on the network, and we'll show this to you. So let's kind of move over here real quick. Okay. Okay, so if we look at the actual data, output data, so let's go ahead and VI this. VI Boston. And this was a real engagement that we extract data out of. And you can see it goes through, in this case it was a Sharp printer. It pulled the actual passwords from. Here's some Snmp strings that were pulled from a device. I think if we come down here too. And there's a device. That happens to be an integrated remote access controller. It actually checks for default creds. So we have a lot of embedded devices where we just validate default creds. And we have some that'll validate default creds and then pull in Snmp data. I think a lot of devices have the Snmp data, but if I haven't found one with it enabled, I really not much for reconfiguring a customer's devices just so I can write my own code and then. So a lot of it's still a growth process in building this tool. And as you can see, it goes through and it shows the ones that failed. showing that they actually, and it's usable data. You want to know which ones are actually possibly configured right and which ones are not. And the Snmp Strings, this last engagement, I was in town working this week, and we ran this tool and we're able to pull Snmp Strings, which gave us access to all their Cisco devices. We were actually able to pull passwords from a number of devices that gave us access to Active Directory also. So probably in the last 4 or 5 months on internal engagements, I've been hitting 100% success rate with foothold data used from gathering from this tool here. And the other one is, kind of look at this real quick, the Boston Web. This is the one that just shows all the fingerprint data that's taking place. So you can see all the different devices I've touched on the network. And you can easily look through this and look for data of interest where you can manually do some of the stuff I'm talking about. Even if there isn't a module, you can quickly spot devices that you can carry out attacks against. And then I encourage you to write modules. You know, look at some of the Perl modules we have here. If you find a device that does basic auth and then basically has SNMP stuff, if you look at the module MA0016, you could literally change the basic auth creds and the input creds for the SNMP string, like 4 fields in there, and get that running first time every time. So a lot of those can be rewritten or modified and used that way. So you can see we can identify a lot of usable data on the network. And looking at Preta itself, so you see the structure here. We have the data file that I mentioned, which is basically the information that's validated or fingerprinted against. So it checks your device, it comes back with 3 possible pieces of information. The title page, the server page is one that's used to fingerprint. The other one is just the SNMP string, so we're doing both of those. And it compares these to the first field, like if we come down here, the HP laser jet right here, it'll look at that, it'll look at the server type. If it gets a match on those, it'll actually run this job, MP0001, and then write the data out to the log file. So you can see we have tons of devices, a total of 73 new devices. The Canon that I just described to you earlier, we wrote modules to actually pull all that on all these different versions of the Canon devices. So we've been getting a little more fancy, and then down toward the end we see the ones that start with the A. These are actually embedded devices. So we can see that we're pulling the PowerCheck. I think this is a Triplite. This one is the Emerson Liebert device. And then we got some various devices and pulling SNMP strings on a lot of these. So we're almost done here. So any questions? Any questions at all? Any positive or negative feedback? Anyone find this useful? Yeah. Okay, good. Yes, sir.
Have you been able to pull interesting data off some of the storage on these printers?
Yeah, that's an interesting take. I have not done that yet. There's a lot of printers that actually can be used to store data. And I've talked to a couple people possibly adding to Pareto an option where you enable that option, because I don't want you just dumping, 20 gig of storage on someone's device. But if you want to do that, the only thing I do here kind of weird that's similar to that is, these small HP office jet printers, the cheap $200 crappy things you use in your house, finding those throughout corporate America now. People are buying them, putting them in their office because they're too lazy to walk 10 feet out of their office to get the print job. These things have a scan bed on them. It's really nice. You can throw interesting stuff on there and scan it. Since they're a little personal printer, what do? You leave that crap sitting on the scan bed. So there is a module in here, if it identifies those, it'll trigger his scan bed remotely and send you a JPEG of whatever's sitting on his scan bed. That's probably the only information style gathering like that. We also just released a paper not too long ago on attacking Xerox Workcentre devices. Check that out. This is basically where the paper will give you entire instructions where to go to get the firmware packages, how to extract the DLM build software out of their firmware packages, how to build your own firmware that won't change nothing on the device, But the run or trigger mechanism, it leverages that to create a bash reverse shell back to you, so you get full root level privileges to the printer's devices. And then from there, you have access to everything. So.
Yep, and their default pins are 0000 or 5555.
Yeah, password's 1111 for most of the Workcentres. There are some that are 2222, and then some of them add an extra one or whatever. But this attack I'm talking about, I've actually written my own job. So if you change your password, and this covers probably over 50% of the brand of Xerox printers out there. So I wrote my own firmware package that all I do is send it to port 9100, and it creates a new URL on the web interface called whatever the root is, called pareda.txt, that'll actually output the administrator password in a file for me. So even if you change your password, I just send it's all it is, I send a print job to it. It creates a file at the root of the server. I pull your password, now I have full password to the device, and then I send another print job, it gets rid of it for me. So yeah, the whole firmware upgrade thing is a print job. I literally port 9100, which isn't protected, and I could do anything I want on the device with root level privileges. Yes, sir.
Have you found the refrigerator or thermostat on someone's network yet? And what's the strangest thing you found?
Oh gosh, you see some bizarre stuff out there. Energy management systems that control temperature control systems and stuff are kind of interesting. Cameras are kind of interesting. Getting useful data off cameras, people just plug them in and never really change anything on them. So I think I've seen like Snmp strings on those a few times that would be fairly interesting. If an organization is really proactive in Snmp managing stuff that's on their devices, then you know, game over most of the time, because they're never proactive to actually change the default passwords. But yeah, cameras are kind of interesting. So the one list, the web host list, where you can just look through and go, hey, what's out there? We've had all kinds of fun. I remember going through there and go, what's this device here? The guy went out to it, turned out it was a camera system at a bus stop, okay? But it had all microphones tied to it too. So we started talking to the guy that was at the bus stop, and he's like freaking out trying to figure out what's going on. So yeah, there's a lot of interesting devices out there, and I expect to see, as you mentioned that device, I expect to see more and more strange devices become apparent on the network that are accessible to do strange things with. So that ought to be interesting in the near future. And of course, this is all based on the fact that everything that's ever made anymore has a web interface on it and a web server. Everything. If it plugs into the network, it has a web server on it. And that's what this whole attack's based on. So, yes, sir.
Who's it maintained by? Is it an individual or a group?
It's
how
basic.
well is it maintained?
Like I said, it's a slow process. I maintain it. I will continue to maintain it until I drop dead or no longer quit doing this.
So you wrote it?
I wrote it.
Oh, I see.
So yeah, it's our team. Our team maintains it. I'm the only one that seems to be creating modules. There's a couple modules in there that have been created by other people. So if you have devices on your network and you can write a quick Perl script, Python, I don't care what you write it in. I'll convert it over to fit to this. But if you can write a script that'll actually pull usable data off any kind of embedded device, send it to me. I'll rewrite it and put it in here, or write me one in Perl. And I've had a couple people generate modules. So it's a project that everything's filtered through our team before it goes into the thing, because I want to check it, make sure it's okay. But everyone's encouraged to get involved in it, especially if you do assessments and pen tests and stuff. It's a tool that actually speeds things up for most pen tests. How many people we have here that do pen testing type work? Okay, so we got a number of people. So I encourage you to give it a try. If you don't like it, tell me why. Let's fix it. Help me fix it. Because it's a tool for all of us. Yes, sir?
You ever tested a hospital?
I do a lot of hospitals. But I haven't added any what's that now?
Embedded medical devices?
I have not added any of those devices to this. I have seen them, but unfortunately I found out there's never any useful data on those. So they never integrate them, they just plug them in. The only devices that were intrigued me were the ones that were wireless. that I could actually pull wireless data off of, the wireless codes, the keys, things like that. That intrigues me because typically if the thing was actually put together by the networking department, it's probably going to match other keys and other key systems, which is the ongoing issue. So I think I've kind of overrun my time. I'll be here the rest of the day. Feel free to hunt me down. Thank you much.
You can take more questions to the post-talk room, and lunch is being served shortly.